Good morning. Today we're going to be talking about the powers of products and quotients. And if you remember from your previous work in mathematics, products relate to multiplying because a product is an answer to a multiplication problem. And quotients relate to division because they're the answer to a division problem. So today what we're really going to be talking about would be raising a product or a multiplication problem to a power and raising a quotient or a division problem to a power. Here we're going to talk about raising a product to a power. So we can see that we have AB raised to the n power, and AB is being multiplied together, and then we're going to raise that to the n power. And if we just expand that using what we know about exponentiation, then AB to the n power means AB multiplied n times. Then if we use what we know about multiplication and just rearrange the A's and the B's, we would have A multiplied n times and B multiplied n times, which would lead us to a general rule that AB to the n power is equal to A to the n times B to the n. It's almost like we're distributing that power to everything inside the parentheses. Let's look at a few examples. In our first example here, we have 3x all raised to the fourth power. Using what we just learned, that means we have 3 to the fourth times x to the fourth. And if we simplify 3 to the fourth, which is 3 times 3 times 3 times 3, which simplifies to 9 times 9, or 81, we have 81x to the fourth power. And I know in previous work that we've often left our, like a 3 to the fourth, we've just left it as 3 to the fourth. But here we will begin to simplify that part out and only leave the exponents on the variables for the most part. Now we have 4x to the third to the second power, and we're going to distribute that second power. So we're going to have 4 to the second power and x to the third to the second power. And using what we now know that we have 4 to the second power is 16, and x to the third to the second power, we're going to multiply those powers and get x to the sixth. X to the fourth times y to the fifth, all raised to the third power. That gives us x to the fourth to the third power times y to the fifth to the third power. And using what we know about raising a power to a power, that gives us x to the 12th times y to the 15th. And looking at the fourth example there, we have 2 times x to the negative 2 to the fourth power. That gives us 2 to the fourth power times x to the negative 2 to the fourth power. Using our power to a power rule, we can see that we have 16 times x to the negative 8 power. And now using what we know about negative exponents, we can change that to 16 over x to the 8th power. Now, here are some for you to practice. You should pause and then come back when you are ready to check your work. Okay, I guess you're back now. And here are our answers. Number 1, 4x to the third power becomes 4 to the third times x to the third, which is 64 times x to the third power. And 10 times y to the fourth power to the second power becomes 10 to the second power times y to the fourth to the second power, which becomes 100 times y to the 8th power. And then 2x y squared, all raised to the third power, becomes 2 to the third times x to the third times y squared to the third, or 8x cubed y to the sixth. And then in problem number 4, we have x to the negative 2 power times y to the negative 3 power, all raised to the negative 4 power. So we get x to the negative 2 power raised to the negative 4 power times y to the negative 3 power raised to the negative 4 power. And when we multiply those powers using our power to a power rule, we get x to the 8th times y to the 12th. Okay, let's look at raising a quotient to a power. Here we have a divided by b, all raised to the n power. And that tells us that we have a divided by b multiplied by a divided by b n times. And if we use what we know about multiplying fractions, we see that we have a multiplied n times in the numerators and b multiplied n times in the denominator, which is going to lead us to the general rule that a divided by b raised to the n power is equal to a over n divided by b over n. Again, it's similar to just distributing that power to both the numerator and the denominator. Let's look at a few examples. In number 1 here, we have 2x divided by 3y all raised to the 4th power. Well, using what we know, or what we just learned with our quotient rule, we have 2x to the 4th power divided by 3y to the 4th power. Now that is going to give us 2 to the 4th times x to the 4th over 3 to the 4th times y to the 4th. And that gives us 16x to the 4th over 81 y to the 4th. Again, that 16 comes from 2 to the 4th. You're multiplying 2 4 times. And the 81 comes from 3 to the 4th. You're multiplying 3 4 times. In problem number 2, we have 5x divided by 4 all raised to the 2nd power. Using our quotient rule, we get 5x to the 2nd power over 4 squared. And then using our multiplication rule, we get 5 squared times x squared over 4 squared. And then when we simplify, we get 25x squared over 16. Again, the 25 is from 5 squared, which is 5 times 5. And the 16 is from 4 squared, 4 times 4. Looking at our third example, we have x to the 5th divided by y to the 7th, all raised to the 8th power. Using our quotient rule, we have x to the 5th raised to the 8th power over y to the 7th raised to the 8th power. Now using our power to a power rule, we have x to the 40th over y to the 56th power. Now, let's have a few for you to practice. You may pause here and then come back when you are ready to check your work. Okay, I guess you're ready to check your work now. And if you look at number 1, you have 2x squared z over 3y squared all raised to the 3rd power. That becomes 2x squared z all raised to the 3rd power over 3y squared raised to the 3rd power. That gives us 2 cubed times x squared to the 3rd power times z to the 3rd power over 3 to the 3rd power times y squared raised to the 3rd power. And when we simplify, 2 to the 3rd power becomes 8. Then we have x to the 6th, z to the 3rd, over 27y to the 6th. And that 27 is from 3 to the 3rd power, which is 3 times 3 times 3. In example number 2, we have 6x to the 4th divided by 5, all raised to the 2nd power. And 6x to the 4th raised to the 2nd power divided by 5 squared is what we get after we apply the quotient rule. And then if we use our multiplication rule or our product rule, we get 6 squared times x to the 4th squared divided by 25. Went ahead and simplified that 5 squared. And 6 squared is 36. So we get 36 x to the 8 over 25. And in our third and final example, we have x to the 5th y cubed over x cubed y all raised to the 4th power. And x to the 5th y cubed raised to the 4th power, then divided by x to the 3rd y raised to the 4th power after using our quotient rule. Now, if we use our product rule, we have x to the 5th to the 4th power times y to the 3rd to the 4th power. Then we have x to the 3rd to the 4th power times y to the 4th. When we simplify, that becomes x to the 20th over y to the 12th, and then x to the 12th over y to the 4th. And then here we can simplify again using division. So 20 minus 12 gives us 8, so we have x to the 8. And 12 minus 4 also gives us 8, so we have y to the 8. Therefore, our final answer is x to the 8, y to the 8. Now we'll take a clicker quiz, and you can show me what you know.